Last time we went through AC and how AC alternated current works in three phases. But let's just consider now one phase, which is the one which is delivered at home, even in your household, for instance. So now, if we consider just one phase and we plot it into our VT graph, time and voltage, we would have a sinusoid which goes up and goes down like this. Now, the reason why it is just that, as we said, the current in AC basically goes half the time in one direction and the other half in the other direction. So it's alternating at 50 or 60 times per second. And if I were to plot the same graph, but for current instead of voltage, I would have, so this one is I, this one is T, the exact same sinusoid. Whoops, yeah, it doesn't actually look the same, but just pretend it's the same. Of course, they won't be the same values, but the sinusoid would actually look the same. Now, it's actually a good time to introduce the concept of phasor. So, if we think about dividing this sinusoid over here as well, and over here as well, and over here, and here, and here. God, doesn't really look the same. I messed up the drawing. Anyway, if we divide this, I'm going to tell you why I've been divided this, and plot this in my XY normal diagram, well, in my graph. So this is X and this is Y. Then I would have that the current and the voltage maximum are sitting one on the T, are two vectors sitting one on the tip of the other. And I like the idea because this is where linear algebra and circuit analysis come together. So this one will be my Vmax. This angle here will be my omega t. And I can actually say that Imax will be Vmax over R. And that IT is actually Vmax over R times the sine of omega t, which is this angle here. Now, this is actually static because I can actually move a piece of paper, of course. But I'm gonna show you what I mean, because these will actually be like this, like this, like this, like this, going on in the other direction. And if they are two vectors sitting one on top of the other, then they're said to be in phase. And the reason why I've been dividing those two into intervals are that so I can divide where the phasors would be. Will be up, left, down, right, up, and the same goes for the current. Up, left, down, right, and up. So if there are two vectors, one sitting on the top of the other, on the tip of the other, then they are in phase. in phase, but it can be out of phase, of course, in particular situation and when they go through some components. For instance, well, in a resistor they are in phase, but if they go through something else like an inductor or a capacitor and so on, they're not gonna end up in space in phase. They're gonna be one, like for instance in an inductor we're gonna have a 90-degree out of phase, and so on and so forth. So now what I also want to say is that I want to introduce the concept of root mean square. What's root mean square? Well, many of you actually know that if I had, well, let's just get back to the graph. Many of you actually think about the current and know the voltage. So they would say, well, in North America, the voltage is 120 volt monophase. In Europe, like in Italy, is 220 volt. In India is 230, and in the UK is 240. But they don't actually know what they mean. They may have heard the word RMS, root mean square, but they don't actually really know what it means. Well, I know what you're thinking. I'm thinking, okay, what if I take the average of this? Well, the average of this is 0 because it's a sinusoid. So it will be half the way, half the time up and half the time down, and then up and then down again, and so on. So if I just take the mean of this, it will be pointless. It will be useless because it will be 0. So now, how can I calculate this if the current is going one way and the other way, and one way and the other way, and so on and so forth? Because I've got to get negative value of the time. So if it's in Europe with 50 years, you would get 25 times negative, 25 times positive going in one and the other direction. So what do we do? Well, you already passed calculus 1 if you're watching this, so the answer to this is pretty straightforward. We have this function here looks really like a sine. As a matter of fact, it is a sine. So what can we do? Well, what if we square it? Sine squared. What happens when you square a function that has negative value like a sine and is periodic? Well, those guys here, which are the negative value, are going to be flipped and they're going to become positive values. So actually, a positive sine wave will be like, let me just, v squared. So if we square it, a square sine wave will be like this, and then up again, and then up again, and then up again, and so on. Because all the part in which was going to be down have been brought back up. Now, we can still say that this one is still gonna be our Vmax, just like before. Okay. But now we have a function which is positive. So now we can handle this. And we can actually make the average. In fact, as a matter of fact, what we're interested in is this part here, the average. Now, if you think about this, v squared, as a matter of fact, it's just Vmax squared times sine squared of omega t. Now, what if I take the average of this v squared? Well, if I take the average of V squared, I'll get 1 over 2 Vmax squared. And if I take the square root, I will have that V squared average will be 1 over the square root of Vmax. So effectively, since you do know that the current in the US, we have 120 volt in a monophase, and in in Italy, like Europe in general, I'm just gonna say Europe, we have 220 volt, and in India we have 230 volt, and in the UK we have 240 volt. What this means is just the root mean squared. So, well, and max, I'm just gonna write n max. So this one is the RMS, the root mean square, what I just found out, okay? So it's just gonna be this, but if I wanna find the peak, so the maximum value, I just have to multiply by the square root of 2. So if I get 120, let me just use another color, Vmax. If I just multiply 120 times the square root of 2, let me just do it here. 120 times the square root of 2. Square root of 2 is this, times 120. I get about 169.7. I will get about, well, I just say about 170 volt. If I do the same for 220, I will get 300. So 220 times the square root of 2, I will get about 311 volt. If I do the same for 230, I gonna get well, I'm gonna get 325 volt. And lastly, if I do the same for 240, which is the one the UK has, I will get 339 volt. So, sorry about that. So in the US, I'm gonna get 170 volt as a peak, 311 volt as a peak, 325 volt as a peak, and 339 volt as a peak. I'll get very sorry about that, I got cold. I shouldn't really be saying those and talk, but anyway, here I am. So as I was saying, in the US I do have 170 volt. In Italy as a maximum, well, I just say at 60 hertz, 50 hertz, 50 hertz, and 50 hertz. So 170 volt as a maximum, 311 volt in Italy, 325 volt in India, and 339 volt in the UK. 50 hertz and then 60 hertz in the US. Gotta say that I've been kind of surprised to say that the UK, yeah, definitely has 240 volts, but in the Commonwealth, there are many differences. For instance, Canada is in the Commonwealth, but is still using and relying on US standards. So 120 volt RMS, 170 volt, Vmax 60 hertz. Also, India was and still is part of the Commonwealth, and it has 230 volt instead of 240. So it's a mess inside the Commonwealth. But anyway, well, at least across Europe is basically standardized by European law. So they're all the same in Italy, in Germany, and so on. So yeah, this is pretty much it.